Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 6 of a unit Laws of Motion. So let's begin with today's class. In previous class we were discussing about the common forces in mechanics. This is the part 2 of a unit of a topic common forces in mechanics. We have already discussed weight, we have discussed the normal force, we have discussed the tension force, frictional forces remaining, and we were discussing certain questions based on the normal force and tension force. So let's just summarize this quickly and we'll back to the tension and normal force. Yes, so let's have a look. What is weight? It is the force acting on an object by an earth towards the center of an earth. Yes, so everybody that exists on an earth is having its weight because everything which do exist having a mass. Second, it was the normal force. It is a force acting between two objects when they are in contact. And it is a push kind of force. This was the normal. Yes, when two objects are in contact, a normal force would be there. If two objects are not in contact, no normal would be acting. And next, it's a tension force. A force exists in strings, or we can say ropes, when it has been stretched or in non-slacken condition is known as the tension force. Yes, it always acts away from the object. It always acts away from the object. I hope these things are clear. So this three forces we have just discussed. The three forces we have discussed about this, and we were discussing the questions on the same. And let's look at the motion of the bodies connected by string. We have already discussed the motion of an objects when they are connected. Now in this situation the bodies would be connected by strings. Let's have a look. The we have two objects. One of them is having mass m1, another one is having a mass m2, and both has been connected by string, as you can see this. And this complete system has been pulled by a force F. Yes, and due to this force F there is an acceleration of the system in positive x direction that has been represented by. So if I work for the all the forces that are being acted on the system, let's have a look. We already know what FBD, it's a free body diagram, is. So this is m1 and this force, it's an m1g, m2, it's an m2g. This normal reaction, or we can write it as an r, or we can write it as n, it's a n1, and this is n2. And as these two bodies are connected by strings, a tension force would be acting. If I write down, look at this very carefully, if I write down the tension force on the m1, it would be acted on this direction, because it is a tension is always away from the body. And if I write it down, the tension on this body, it's a body of m2 mass, it would be in negative x direction because it is the away from the body. I hope those things are clear. One more thing, this tension and this tension, this are creating, this are forming the action reaction pair, so they should be same in magnitude but opposite in direction, as you can see it. Great. Now what would be the first step when we are used to discuss the connected bodies? Yes, first thing is always to find out the acceleration. What acceleration is? The acceleration is f total divided by m1 plus m2. The acceleration is always f divided by total mass to be carried, which is equals to m1 plus m2. Now if I want to find out the tension, if I want to find out this tension force, what I can have, it's a T is equals to m1 into a, that could be written as acceleration could be having, it's an m1 into f divided by m1 plus m2. If you have gone with this, with the m2, let's have a look. This is the m2, this is the force F, and this is the tension T, and this system is moving in this direction. So as it is moving in this direction, F must be higher than the T. What I can write, it's a F minus T should be is equals to m2 into a, and this is equals to F minus T should be equals to m2. Let's just replace the value of a, it's an F divided by m1 plus m2. So when and when you are going to solve this, it would be T is equals to m1 into F divided by m1 plus m2. Look at this, the tension on this and the tension that we have derived with the help of m1 block, both are the same. As we discussed that it is the action reaction pairs, so their magnitude must be equal and the directions are opposite. But you can go with this or you can go with this. It is your practice that will tell you that if I choose the m1 block to find it out, the tension will be much easier or much less calculative as compared to the chosen of the m2 block. But that is all about practice. So as soon as you are going to practicing this, you will be know that this would be the faster approach. I hope this is clear. Let's look at the second system. Suppose instead of two, now there are three bodies. One is the m1, another is the m2, another is the m3, and this is being pulled by this force F. So what I need to find out, I need to find out these two things, tension at first body and tension at the second. It's a T1 and T2. So when and when it's a connected motion, it is the case of connected bodies, and when bodies are connected, their acceleration must be equal, that we have learned in the previous class. Its acceleration is same, and when acceleration is same, acceleration could be written as f total divided by total mass to be carried. The total mass is m1 plus m2 plus m3, so a is equals to, acceleration is equals to f total divided by m1 plus m2 plus m3. Now let's just calculate the t1, what it would be. You can understand that as force is acting in this direction, your acceleration must be in this direction. So T1 is producing a times of acceleration of its mass. So T1 is equals to m1 into a, and let's just replace the value of an a, which could be written as f divided by m1 plus m2 plus m3. I hope these things are clear. Is it clear? Yes. Let me just show you the diagram. It's an m1, m2, m3, and this has been pulled by certain force F in this direction. We have find out the T1, and now we are working for the T2. This is the situation. So when and when I write the T2, when I write the T2, which all two blocks I need to carry. Look at this. If you pull it from here, if you pull it from here, you are going to carry M1 and M2 with you. So that could be written as T2 is equals to M1 plus M2 into acceleration. It is something like this. T2 is equals to M1 plus M2 multiplied by acceleration, and that acceleration can be written as F divided by M1 plus M2 plus M3. Yes, and this T3, if I can write it is the same as the force F. So T3 is equals to F. I hope these things are clear. Is it clear? Let's move for the questions. Yes, this will make concepts much better clear. Let's have a look. That three blocks are there. Three blocks of masses M1, M2 and M3 are connected by a massless string as shown in the figure on a frictionless table. They are pulled with a force of T3 which is equals to 14 Newton. Yes, this is given. If M1 it is equals to of 10 kg, M2 6 kg, M3 4 kg. What I need to find out? I need to find out the T2. Great. So let's start working for this. First task, it's an acceleration that should be is equals to F total divide by total mass to be carried. It's an M1 plus M2 plus M3. The F total it is of 14 Newton. The total mass to be carried, this is 10 plus 6 plus 4. It's a 10 plus 6, 16 plus 4, it's a 20. So the acceleration of the system would be equals to 2 meter per second square. Now what do I need? I need the tension T2. Let's have the diagram one more time and let's just try to calculate it. The situation is that this was a 4 kg block, this was a 6 kg block, this was the 10 kg block. Here the tension was, this was the T1, T2 and T3. Okay, great. This is T1, this is T2, and here it's a T3 which is equals to 14 Newton. That has been given in the data, and at first I am interested with T2. So what I can do is that if I find it out on the 6 kg block, I have two options, such as that let's just make an FBD of 6 kg block. This is T2, this is T1, and my system is moving in this with the acceleration A that I have calculated, which is of 2 meter per second square. So this could be written as T2 minus of T1. That should be is equals to mass times of acceleration. This is 6, this is 2, so that should be 12. But the problem is I'm not having a value of T1. So what I need to do, I need to first find it out the value of T1. So this T1 for T1 I need to make an FBD, free body diagram, of 10 kg block, and this is T1. Yes, so what I can write, it's a T1 is equals to mass into acceleration. This is equals to 10, acceleration is 2, this is 20 Newton. I hope these things are clear. This is the T1. So let's just replace the value, T2 minus of 20. So this T2 is equals to 12 plus 20, which should be equals to 32 Newton. I hope these things are clear. Is it clear? Is it? So can you do this? Are you sure? Are you sure? Now, may I have anything which is just the shortcut of this? Anything? Let's have a look. It's an alternate approach. So what can I do is that let's have a sketch of this. This is of 10 kg. This is of 6 kg. This is of 4 kg and this is of 40 Newton. I know that acceleration is 2 meter per second square. This was the T1 and this was the T2. This are the tension T1 and this are the tension T2. So when and when I need to find out the T1, let's just try to feel it, that when and when I am going to pull from this situation, from this block, only 10 kg block will be moving with me. Yes, when I'm going to pull from this, only 10 kg block is moving with me. So I can have, it's a T1 is equals to mass 10 kg multiplied by acceleration, which is equals to 10 multiplied by 2, which could be written as 20 Newton. Is it clear? Is it? Great. Now when you are going to pull your system from this point, when you are going to pull your system from this point, that is the T2, you are going to pull 6 kg block as well as 10 kg blocks. So what you require, it's an M total multiplied by acceleration. The M total for T2 case, it would be a 10 plus 6 multiplied by acceleration, which is a 2. It's a 16 into 2, which could be written as 32 Newton. That's it. You did it. I hope these things are clear. Is it clear? Is it? So this is the logic correct approach, but it might take a longer amount of time. This is a logical approach which will be carried out, within probably the shorter amount of time. Yes, you can go with which you are comfortable with. Yes. Okay, great. Let's work for the next question. Let's suppose the situation is something like this. This is 5 kg block, this is 3 kg block, this is 2 kg block. Yes, from here it's a force of 30 Newton, from here it's a force of 10 Newton. What you need to find out? You need to find out this is tension T1, you need to find out this is tension T2. So the question is, find out tension T1 and T2 as shown in figure. So this is your requirement. You need to find out the tension T1 and T2 as shown in the figure. How should you get it done? Yes, the basic approach remains the same. First, find out the acceleration. What is it? It is F total divided by total mass to be carried out. The total mass. Yes, first F total, what is it? 30 Newton is acting in positive x direction, 10 Newton is acting in the negative x direction. So this is 30 minus of 10 divided by total mass to be carried. It's a 5 plus 3 plus 2. It's a 5 plus 3, 8, 8 plus 2, 10. So this is equals to 20 divided by 10, which should be 2 meter per second square. I hope these things are clear. Is it clear? Great. Now let's work for the T1 and T2. So for the T1 I need to have an FBD of the 5 kg block. So this is the situation. This is the 5 kg block, this is 10, and this is T1. Now in which direction my system should move, whether it is in positive x direction or in negative x direction? What is your conclusion? Yes, it should be in positive x direction. How should I come to know? It's a 30 Newton force, it's a 10 Newton force, as this force must dominate, so my system must move in this direction. This should be the acceleration. So this should be the acceleration, and if this is the acceleration, what I need to write is T1 minus of 10 should be is equals to 5 multiplied by acceleration. So when I write this, it is T1 minus 10 should be is equals to 5 into 2. So this T1 is equals to 10 plus 10, which should be equals to 20 Newton of force. I hope these things are clear. Is it clear? Is it? Great. So this is the T1. Now let's work for the T2. Shall I redraw this? Shall I? Let's have a look. It's a 5. It was 3 kg block. It was 2 kg block. This has been pulled by 30 Newton and this has been pulled by 10 Newton. My system was moving in this direction and I was working for this T2. I have been with T1 and the value of T1 was 20 Newton that I have calculated in the previous slide. Now let's work for the T2. How could I do this? I am having two approach. One of the approach, I can go with the 3 kg block and its FBD. Another approach is with the 2 kg block and its FBD. Let's work with the 3 kg block. This is 3 kg block. Here T2 would be there. Here T1 would be there because tension always acts away from the body. This is the acceleration. So T2 must be higher at T1. So this is T2 minus T1 is equals to 3 into acceleration. My acceleration was 2 meter per second square. So this is T2 minus of T1. T1 is of 20 is equals to 3 2s, which is 6. So this T2 should be equals to 20 plus 6. It's a 26 Newton. I hope this is clear. Okay. Would you like to see if I have chosen a 2 kg block? If I have chosen 2 kg block, what would be the situation? Let's have a look. That let's suppose this is the 2 kg block. This is the 30 Newton and this is the tension T2 and my system is moving in this direction. So which force will dominate, 30 Newton or tension? It is obvious that as my system is moving in positive x direction, 30 Newton force will dominate over T2, and when it is dominating, it's a 30 minus of T2 should be is equals to 2 into acceleration. Acceleration is of 2, it's a 2 2s are 4, that should be equals to 30 minus T2. So this T2 should be equals to 30 minus of 4, which should be 26 Newton. Yes, the answer is the same because it is the action reaction pair, and when there is an action reaction pair, they must be same in magnitude and they are opposite in direction. Yes, something like this. I hope these things are clear. Is it clear? Are you sure? Great. So now, will you able to solve this kind of questions? Will you be? Are you sure? Are you? Great. Now let's look for the second category of questions. Let's say a road is there having mass m, having length l. Here it is a point P, here it is a point P, and this distance is x. So the question says find out tension acting at point P. This is the requirement. Find out tension acting at point P. So what you need to do and how could you do this? How could you do this? So what I understand from the diagram is that I can divide this situation into two blocks. One of the block is, this is the mass m1, let's say, and this is the mass of m2 block. Yes, this is the length l minus x, and this is the remaining block, it's an x. And what I want to require, I required this is my point P, and I require tension at this point. So what I can write is that tension at P is equals to, if I draw the rough sketch of this is the M2, this is the tension at point P, and this is the mg. So this could be written as Tp should be equals to m2g. But the problem is I'm not having given the mass of m2, so I need to find it out that mass. How could I write down the m2? So let's look at this very carefully. What I can do with this is Tp is equals to m2g. Now I need to calculate this mass m2g. So please remember this. How I should write it? Let's have a look. I understand that the total mass of this road is m divided by total length. It's a mass per unit length multiplied by the length for which you have used this mass. It is an x multiplied by g. So this is the value of an m2. It's an m by l multiplied by x multiplied by g. This is the value of a tension at point P. I hope this is clear. Is it clear? Is it any doubts on this? Anything? Anything? No? Great. Let's work for one more question and things will be better. Let's suppose this is road having mass m, length l. You want to find out the tension at this point P, but this is at distance x. So the question is find out tension at point P. This is the requirement, find out tension at point P. So what you need to do is that divide this into two blocks, m1, m2. This is of x length, so this is obvious. This is will be of l minus x. Here it would be a point P. So what you need to do? Yes, you understood it correctly. It's a Tp which should be equals to m2 into g. Yes, how this has been arrived? It is something like this. This was m2. The force on this point, it's a Tp. The force on this point, it's an m2g. So Tp is equals to m2g, but I'm not having the value of a mass m2. So what I need to do is this is Tp is equals to m2g. I need to find out the value of a mass m2. How should I write this? It's a total mass m divided by total length l multiplied by use that amount of length that has been used. It's an l minus x. So this is l minus x multiplied by g. This is the tension at point P. I hope these things are clear. Is it clear? Is it? So can I have one more variation? Can I have? Yes. You find this interesting? Yes. Let's work for this. Suppose this is mass m, this is length l, and here it's a point P, and this distance is x. Now suppose the twist is that this complete system is moving in upward direction with acceleration a. Then now you need to find out tension at point P. What should be the answer? Tell me. What should be the answer, or how should you evaluate this? How should you evaluate this? So the basics remains the same. What you need to do, divide this into m1 and m2. This is m1, this is m2, this is x. This must be an l minus x. Here point P would be there. Yes, and this system is moving upward with acceleration a. So if you draw this FBD of point P, it would be something like this. This is m2. At this point it's a tension at point P. Here it's an m2g, and this system is moving upward in. So as it is moving in upward direction, tension at point P will be dominating as compared to the m2g. So this could be written as Tp minus of m2g should be equals to m2a. How this has been written? Yes, Newton's second law. What is what? It was sigma f is equals to mass into acceleration. Yes, so yes, you understand this. Great, well done. So now now what you need to do is you need to just write down the mass of the M2. So this is Tp, which should be is equals to M2 into bracket G plus A. M2 could be written as complete mass, total mass M, total length L multiplied by you have used for the length L, X multiplied by G plus A. Yes, this is tension at point P. Great, well done, good job. Do you understand this? Do you? Any issues? Any query? Any difficulties? Take your time. Look at this for 10 seconds. And is there anything which is not to be understood? Are you sure? Great. Let's work one more question based on the same concept. This is the situation, and now it is moving in downward direction. The total mass M, total length L. Yes, this is point P. The question is find out tension at point P. This is the requirement. So let's do the same task again and again. This is M1, this is M2. As it has been given, this is length X, so this must be L minus X. Yes, now you want this, it's a tension at point P, and this is moving in downward direction with an acceleration of A. So this is M2, this was tension at point P, this is M2G, this is moving in downward direction with an acceleration of A. M2G must be dominating Tp, so this is M2G minus of Tp should be is equals to M2A. So this Tp could be written as M2G minus of A. The M2 could be written as total mass M, total length L multiplied by with the length L minus X into bracket G minus of A. This is tension at point P. I hope these things are clear. Is it clear? So now I hope you can have a command over this kind of questions. Are you sure? Okay, great. So let's work out for one of the question, a same concept of question, but it is the concept of the normal force. Let's suppose it is the block, and this is the block of 30 centimeter, and this block is having a mass of 3 kg. Yes, at somewhere here this is a 20 centimeter, a point P is there, and from here it has been pulled, with a force of, let's say, 9 Newton. Yes, now what they want is find out contact force is acting at point P, as well as one note is given that assume that mass is uniformly distributed. So distribution of mass is uniform, and you need to find out the force that is acting at point P. So how should you do this? So if you observe very carefully, this is a block of 3 kg and the total length of this block is 30 centimeter. So what you can do is that you can just divide for your understanding in two blocks. This is the block of 20 centimeter and this is the block of 10 centimeter. This has been pulled by the 9 Newton. Yes, when it is a total block is of 30 centimeter and total mass is 3 kg, that means 10 centimeter block. That means 10 centimeter block should be of 1 kg and 20 centimeter block should be of 2 kg. I hope this is clear. You want a contact force between this point. Yes, even you can understand. For your understanding, you want to find out the tension at this point. This is for your understanding only. Yes, so what you need to do, you need to find out first acceleration, which is F total divided by total mass. The F total, it's a 9. The total mass, it's a 3 kg, which would be a 3 meter per second square. Now what you need to find it out? You need to find it out the normal force at point P. So if you want to find out the tension or normal, that can be given as at point P is it's a mass multiplied by acceleration. The mass is of 2 kg, acceleration would be of 3. This is equals to 6 Newton. That's it, you did it. Great job. I hope this is clear. Is it clear? Any doubts on this? Anything? Any doubts on this? No? Great. So do you understand the situation? Do you understand the situation? Are you sure? Can it be done? Can it be? Great. Well done. So I hope you are comfortable with this kind of questions. Yes, this is the rigid body dynamics, but this is of linear distribution of mass, where mass will be distributed uniformly. Yes, so now let's switch to the special cases of pulley, and it's a motion of the bodies connected by string passing over a smooth pulley. The situation would be something like this. I hope you understand the pulley. Do you? Yes, this is M1. This is M2. Yes. So let two bodies are there, which is an M1 and M2, respectively are connected by a light inextensible string. It is the case of an ideal string. When they say it's an ideal string, that means it should be a massless, it should be an frictionless, and it is, or it should be an inextensible. Yes, so if they say and it has been connected by an ideal string, you can understand the three factors. First, massless, another frictionless, another inextensible. Yes, so the thing is that these two blocks M1 and M2 have been connected with the strings that is passing over a massless smooth pulley, and let's suppose we have assumed that M1 is greater than M2. So when we assume M1 is greater than M2, this block should be moving down with certain acceleration A, and this block should be moving with acceleration A. If M1 is moving in downward direction, it is obvious that M2 is moving in the upward direction. I hope these things are clear. Is it clear? Is it clear? Great. Now let's just write down the relations. Before that, let's just have the free body diagram of the situation, that this is M1, this must be the tension T, This is the force that is acting in downward direction, which is m1g. This is m2g, and this is the tension that is acting in the upward direction. Now, if you observe this situation, the situation of m1 block, it is moving in the downward direction, and if it is moving in the downward direction, it's an m1g minus of t, that should be is equals to m1a. And if this is moving in the upward direction, this is t minus m2g is equals to m2a. So this is relation number 1, this is relation number 2. If I solve this two relations, if I solve this two relation, I am having this, that EA is equals to m1 minus m2 divided by m1 plus m2 into g, and the tension that could be written as 2m1 m2 divided by m1 plus m2 into g. Yes, one more thing, a reaction of the pulley, that means the force acting at this point, it's a reaction on the pulley. If you understand this very carefully, then you must understand that this is the pulley, this is the force R, this is T, this is T. For pulley, this two tension should be in the downward direction, because tension always acts away from the body. So R reaction force would be equals to twice of tension force, and that can be written as 4m1 m2 divided by m1 plus m2 into g. I hope these things are clear. Is it clear? Is it? So this is the one of the approach, this is the one of the approach that we have written this relations, and then we will go, then we will move with the solution of this using any of the approach, that means the cross multiplication, or you are just going to eliminate any one of the factor and put the value of the second and something like this. Yes, and then you will have the answer. Now one more approach could be there, one more approach could be there. Let's have a look at this. So, and that approach can be written as, let's look at the situation very carefully. Our situation was something like this, that this was the m1 and this was the m2. Yes, now we have one relation which says that acceleration A can be written as, it is a net pulling force divided by total mass to be carried. This is the net pulling force divided by total mass to be carried. Now, first thing, what is pulling force? So as a pulling force, I'm going to use mg only. So mg, that is acting in the downward direction. Let's assume it as a positive, or I should understood as that 4m for block whose which is moving in downward direction. This is m1g, this is m2g, but according to the R cases, m1 was greater than m2. So whichever the block, let me write it down clearly so that it doesn't have any chances of misconception. So block which is moving in downward direction, considered its mg positive. So you are smart enough that you understand that block which is moving in upward direction considered its mg as a negative. Yes, I hope you understand this. that one of the force, if block is moving in downward direction, if I consider its mg as a positive, then for another one, the block which is moving in upward direction, that mg should be considered as a negative. So this is net pulling force, which could be written as m1g minus of, why minus? Because if this is moving in downward direction, this must be moving in upward direction. So this is m1g minus of m2g divided by m1 plus m2. I hope this is clear. So from this acceleration can be calculated very easily. And if I can calculate the acceleration, I can have the rest amount of terms. That means I can have the tension at whichever place you want, because you understood well that how the relations according to the Newton's second law can be written. And if you can write this, you will have the answer. I hope this is clear. Is it clear? Is it? Is it clear? Are you sure? Are you? So, ready for the questions? Are you sure? Let's have a look. So the question says that this is the pulley system. This is the 7 kg block. This is 3 kg block. What you need to find out? You need to find out acceleration and tension. Yes, acceleration of the system and tension in the string. So what do you need to write down? Acceleration first. Acceleration is equals to net pulling force divided by total mass to be carried. So net pulling force, it is, as you can see, it's a 7 kg, it's a 3 kg, so this should moving in the downward direction and this should be moving in the upward direction. So that should be equals to 7 into g minus of, why minus? Because this is moving in downward direction, considered as a positive. So as this is moving in upward direction, I need to consider it as a negative. So 7 into g minus of 3 into g divided by total mass to be carried. This is 7 plus 3 with 7 plus 3, which should be at 10 kg. So this is 70 minus of 30 divided by 10. This is equals to 40 by 10, which should be a 4 meter per second square. I hope this is clear. Is it clear? Is it? Great. Now, as you can understand, this is 7 into g and this is the tension. Now you need to find out the tension force. You understand the value of acceleration and this is moving in the downward direction, so 7g must be dominating the tension force. So what I can have, it's a 7 into g, that is of 10, minus of t, that should be is equals to 7 multiplied by acceleration. So this is 70 minus of t, that should be equals to 7 4s are 28, and from this it is t, which is of 7070 minus of 28. This is equals to 28 plus 2 30, 30 plus 40, it's a 42 newton of force, 42 newton of tension force is acting. Yes, yes. What was your answers? Is it same? Is it? Yes, even this can be done with the same. It's an, if you remember the formula, that could be written as m2 minus of m1 divided by m1 plus m2 into g. So this is equals to 7 minus of 3 divided by 7 plus 3 multiplied by 10. This is 4 by 10 multiplied by 10. This is equals to 10 meter, sorry, which is equals to 4 meter per second square. Yes, the tension, it's a 2m1 m2 divide by m1 plus m2 into g. So that should be equals to 2 multiplied by 3 multiplied by 7 divided by 3 plus 7, 10 into 10. This has gone. So this is 7 3s are 21, 2s are 42 Newton. But for this, you must remember this formulas. And every time it is not possible to remember the formulas. Every time it is just not the possible. And when formula remembering is not possible, only the concept will save us, and this is the concept. I hope this is clear. Yes, so go with this. If you understand this well, you do not need to remember anything. Yes, just go with this relation, that acceleration is equals to net pulling force divide by total mass to be carried. I hope this is clear. Is it clear? Is it? Let's look at one more question. That the question is something like this. This is 4 kg block. This is 2 kg block. This is 4 plus 2, 6. And this is again a 4 kg block. What do you need to find out? First, find acceleration of the system. Second, tension at this and tension at this. So find T and T1. So these two are the questions. First, you need to find out the acceleration of the system, as well as you need to find out the tension in the string at the which I have mentioned as a T, and I need to also calculate the tension T1. So how could we do this? What could be done to this? What I can understand is that let's suppose this is the pulley and this is the 4 plus 2 6 kg block, and this is a 4 kg block. So if I want to find out the acceleration, it is just the net pulling force divided by total mass to be carried, which is 6 into 10 minus 4 into 10 divide by total mass. It's a 6 plus 4, which is a 10. So this is 60 minus 40, which is a 20 by 10, which should be 2 meter per second square. It is the acceleration of the system. Now to find out the tension T, what I can have, it's a 2 multiplied by m1 multiplied by m2 divided by m1 plus m2. It's a 6 2s are 10. So this is 6 4s are 24 divided by 5 Newton. Yes, this is 24 divided by 5 Newton, which is a 4.8 Newton. I hope this is clear. Now, how should I find it out the T1? The question is, how should I get it done? So, if you understand the situation very carefully, this is 6 kg block, this is 4 kg block, and as it is of higher in mass, these should moving down and this should moving up. So this is moving in downward direction. So the situation is that this is the 2 kg block, this is 2 into g, and this is the tension T1, and this is moving in the downward direction with an acceleration which is 2 meter per second square. So let's just go with the concepts. It could be written as 2 into g minus of T1, that should be written as 2 into a. This is 20 minus of T1 should be equals to 2 into 2, which is of 4. So T1 could be written as T1 is equals to 4 plus 20, which is 24 Newton. That's it, you did it. So always concepts as well as formula can go hand to hand with each other. Yes, But you can remember the formula, but it doesn't mean that if you forget the concept it will work. It will never work. Yes. So I'm trying to cover concept as well as formula both. Yes. So when I'm trying to cover it, you need to go with both the situations. You understand the concept, remember the formula, and apply it carefully. I hope these things are clear. So is it clear? Can you do this kind of questions? Can you? Okay, let's just have a look to the second situation of the pulley. Let's have a look. The situation is that suppose a table is there and body with mass m2 rests on a smooth table and mass m1 is connected. Here it has been connected. Mass m1 is connected to m2 by a light string over a pulley fixed at the edge of a table, and it hangs freely. If m1 is greater than m2, then the equation of the motion. So what could be written? Let's have the FBD of this on. I'm going to write down the all the forces that is being acted. It's m1g. This is the tension as they are connected with the same string, so the tension would be same. Yes, for m2 away from the body is in positive x direction, so this is tension T. And as they said m1 is greater than m2, that means this is moving in downward direction, and if it is being pulled in the downward direction, this must be pulled in the positive x direction. So this would be the situation. Now let's write down the relations according to the second law. It's a sigma f is equals to mass into acceleration. So for body A, for body m1, it is moving in the downward direction, so m1g must be dominating this. So that could be written as m1g minus of t, that should be is equals to m1 into a. And for body m2, this can be written as t is equals to m2 into a. So for this I'm having, this is first relation, this would be the second relation, and when these two relations are there, if I try to solve this, it's an A which is equals to m1g divided by m1 plus m2, and the tension could be written as m2 into a, and if I replace the value of a, it is m1 m2 divided by m1 plus m2 into g. Yes. Is it clear? Is it clear? Are you sure? Okay, so this is the approach where certain theoretical parts has been used. Now let's look at the second approach. Same for the same situation, this was the m2 and this is the m1. Yes. So acceleration, it's a net pulling force divided by total mass to be carried. So when I write net pulling force, what I understand, it's a m1g in this direction, it's a t in this direction, it's an m2g in this direction, it's a t in this direction. That is correct, absolutely correct. But tell me one thing, that does m2g is moving in downward direction? Does it moving in downward direction? Your answer must be no. Yes, that because m2g, this m2 block is moving in horizontal direction, not in the vertical direction in this situation. Please ensure yourself that I'm not telling you that m2g is not acting. It is definitely acting, but while I observe the motion of m1 and m2, m2g doesn't play any role in the motion. Am I clear? Or shall I repeat it? I am observing at this point of time only the motion of this pulley and this block system. So if I observe this, my M1 block is moving in downward direction and my M2 block is moving in positive x direction. So in this situation I need to consider as a pulling force only as an M1G. So this is M1G divided by total mass to be carried, which should be an M1 plus M2. This is the acceleration without having any derivation. I hope this is clear. And once you are done with the acceleration, you can write it down. The tension force as well. It is T is equals to M2A. Done it. Yes, replace the value of A and the things will be done. And if you go with this, it's M1G minus of T would be equals to M1 into A. That's it. You did it. Great job. I hope this is clear. Is it clear? Is it any doubts on this? Anything? Anything? No? Great. Let's work for the question that this is the situation. This is of, let's suppose, 3 kg and this is of 5 kg. Yes. So the question is find out acceleration of the system. Also find out tension in the strings and reaction force on the pulley. Yes, you require this. So let's target this one by one and try to get it done. First, I need to find out the acceleration of the system. So how could I do this? The acceleration could be written as net pulling force, which is a phi into g, divided by total mass to be carried. It's a 5 plus 3, which is 8. So this should be 50 by 8, which could be written as 25 by 4 meter per second square. Done. Yes. Now this is the tension T, this is the tension T, and this is phi into g. So the shorter approach will be equals to T is equals to 3 into A. This is the shorter approach. Yes. So let's work with this. That tension force T is equals to 3 multiplied by acceleration. It's a M into A. So this is 3 multiplied by 25 by 4, which should be is equals to, this is 75 by 4 Newton. Yes, this is correct answer. Even if you wish, then you can go with this. It's a phi into g minus of T is equals to phi into acceleration. This is the alternate approach, but never do this. Yes, because it is time consuming. Yes, but according to the physics it is absolutely correct. So this is 50 minus of T is equals to phi into A, which is of 25 by 4, which is equals to 50 minus T. 25 5 it's a 125 by 4, and get it done. It's a 125. 50 minus 125 by 4, which is 75 by 4 Newton. So answer would be the same, and it is expected. Now, so we have done this. We have find it out the acceleration. We have find it out the tension in the strings. Now only the thing that remains is the reaction force on the pulley. How could you find it out, the reaction force on the pulley? How could you? So if you make a sketch of pulley, a situation is something like this. For the pulley, this tension is acting in this direction, this tension is acting in this direction. It is always away from the body. Yes. So this t and this t, this t and this t, this should be a root of 2t. This is root 2t. Yes. So the reaction force on the pulley R should be is equals to root 2t. I hope you understand how root 2t has arrived. It's a R that should be is equals to under root of t square plus 2 into t into cos of 90 degree. Yes, so this is 0 and this is root of 2t. Yes, so this is equals to root 2 multiplied by your tension force, which is 75 by 4 Newton. This is the reaction force on the pulley. Is it clear? Is it? So can you do this kind of questions? Will it be possible for you guys to get it done within given time frame? Are you sure? Can it be done? Can it be? Great. So ready for one more? Let's have a look. This is the situation. If in the system shown in figure m1 is greater than m2, I need to find out the acceleration a of the system. How should I done this? Yes, so let's have a diagram of this. Let's suppose this is m2. That should be is equals to m2g. We understand all this. Yes, this is m2g sine beta, and this is sorry, this is m2g cos beta, and this is m2g sine beta. Same way here m1g, here it's an m1g cos alpha, and this is equals to m1g sine alpha. What I need to find out? I need to find out the acceleration, and then I need to find out the tension. So what I need to do is that suppose this is the alpha, this is beta. Acceleration A should be equals to net pulling force divided by total mass to be carried. Yes, the acceleration should be is equals to net pulling force divided by total mass to be carried. Now how could I find out the net pulling force? Look at this, where my motion of this pulley is going, where it is going to move, in the direction of sine alpha or in the direction of sine beta component. And as they mentioned m1 is greater than m2, let's just assume that it is moving in the downward direction. So if it is moving in downward direction, it is moving in upward direction. So if I write down this, it's a m1 sine alpha minus m2 sine beta multiplied by g divided by total mass to be carried, which is m1 plus m2. Now once you have been gone with this, once you have been done with this, you can easily calculate the tension in the string. Yes, how could you do this? That could be written as that as it is moving in downward direction, I can have this. It's a m1g sine alpha minus of t should be equals to m1 into a. Yes, if you want to go with this, it should be an, as it is moving in upward direction, tension would be higher as compared to the m2g sine beta. So this is t minus of m2g sine beta should be is equals to m2 into acceleration a. Yes, if you want to remember this, you can have this. Yes, but I advise not to remember this. Yes, it doesn't make any sense. If you are through with this situations, once you are having an acceleration, it would be very easy It would be very easy, and you can do it in fractions of seconds to find out the calculation of the time tension T. Yes, so not advisable to remember this, but if you wish, you can go for it. Yes, and the reaction force, it is equals to 2T sine alpha plus beta by 2. Yes, I hope you remember this. Yes, so can you do this kind of questions? Can you? I hope you will be comfortable. You will be comfortable with the questions that has been asked based on the values. Is it? Is it? Okay, great. So ready for the next question? Ready for the next situation? Let's have a look. Suppose the situation is something like this, that here m1 is there, here it is an m2, and as I mentioned m1 is greater than m2, so this must be moving downward, and as this is moving downward, this m2 is moving upward. But when m1 is moving downward and m2 is moving upward, that means this block having mass m is moving in this direction with acceleration a. So you need to find out the acceleration, you need to find out the acceleration, and you need to find out the tension in the string. That means, but everything is having a different tensions. Why? And how could I evaluate that tension would be the equal or tension would be the different? So what I understood is that when one string is same, tension would be the same. So look at this string, just go with this string. Yes, it is the same string, so they are having same tension, T1 and T2, T1 and T1. Look at this string, it is the different string. Yes, so this complete string having the same tension, it is a T2 and T2. Yes, and as you must understood that as this is moving downward, this is moving in forward direction, I'm talking about this capital M. That means my mass sorry, tension T1 must be greater than tension T2. Yes, I hope these things are clear. Is it? So let's just write down the relations based on this. So let me draw the rough sketch. This was capital M. This is M1. This is M2. Yes, this was the T1. This was the T2. Yes, as it is mentioned that M1 is greater than M2, and when I have mentioned that is M1 greater than M2, this must be moving in downward direction, this must be moving in upward direction. So let's just write it down. It's a M1 of G. So this is M1G minus of T1 is equals to M1A. This should be M2G, but as it is moving in upward direction, that means T2 must be dominating M2G. So that could be written as T2 minus M2G is equals to M2A. And the third relation, as it is moving in this direction, this is equals to T1 minus T2 is equals to M into A. Yes, so if we solve this, because we have three relations, relation number 1, relation number 2, relation number 3. Three relations, three unknowns. Which are they? It's an acceleration, tension, and T2. Three unknowns, three relations can be solved very easily. If not, if you wish, you can remember this, but maybe according to me this is none of use. Yes, so please go with the concepts, put up the value, and try to find out the acceleration, and that can be done easily. Yes, maybe it will take a certain amount of time, maybe 1.5 or 2 minutes, but that can be spent on this, and we do not have any other options. Yes, I hope these things are clear. Is it clear? Are you sure? So can it be done? Can it be done? Would you like to have one more situation? Would you like to have this? Let's have a look this. This is the situation when the two masses m1 and m2 are hanging as shown in the figure, and it has been mentioned that M2 is greater than M1. So the situation is, this is M2, this would be the M2G, this would be the tension T, and as mentioned it is moving in downward direction, and as it is moving in downward direction, this must be moving in the upward direction. This is the acceleration. So so let's just write it down, the two relations. First, it's a M2G minus of T, which is equals to M2A, and the second it's a T minus M1G sine theta, that should be equals to M1A. From this you can easily calculate the acceleration and, if required, a tension as well. I hope these things are clear. Is it clear? Is it? So will you able to solve this kind of situations according to the formula or according to the concepts? Is it possible for you guys to get it done? Will it be? Are you sure? Can it be done? Can it be? Are you sure? Okay, great. Let's have a look. So the question is, this is 30 degree. Here one of the block is there. It is of, let's say, 6 kg, and this is of 10 kg. Yes. So what do you need to do? Find out acceleration of the system and tension in string. So this is 10 into G, this is tension T, this is its acceleration. As this is moving in downward direction, this must be moving in upward direction. This is tension. This is 6 into G into sine of theta. So let's write down the relations. It's a 10 into G minus of T should be equals to 10 into acceleration A. This could be written as T minus of 6 into G into sine 30 degree. It's a 1 by 2. That should be is equals to 6 into A. So this is equals to, this is relation number 1, this is relation number 2. Let's just try to solve this. It's a 10 into G, which is 100, minus of T should be equals to 10 into A. Or relation number 3, it's a T minus 6 into G, it's a 60 by 2, which is a 30, should be is equals to 6 into A. This is relation number 4. Yes, let's just add this. If you are going to add this, it's a minus of T and plus of T, minus of T and plus of T, this would go on. So this is 100 minus 30, it's a 70, that should be equals to 10 plus 6, it is a 16 into acceleration. So the acceleration, it is of 70 by 16, or we can say 35 by 8 meter per second square. From this, put a value of acceleration at any of the relations and you will find out the tension. So find tension T. It's a try yourself. I hope this is clear. Is it clear? So can you do this? Can you? So is it possible for you guys to get this done? Is it? Great. So let's just wind it up this session over here, and we have been working for the tension force, and we were discussing about the connected bodies. So up till now, in the common forces and mechanics, we have done with the weight, we have done with the tension, we have done with the normal forces. In the next session, that means from the next sessions, we are going to discuss about the friction force. But when and when we use a friction force, we are going to use the forces weight, normal as well as tension when I am going to discuss the weight friction. So please do as many questions as possible. Please practice a lot, because as I said in the first class, this is the heart of a physics that we are discussing. Yes, so please do as many questions as possible. At least 60 to 70 questions of each force is required. Please do it. If only the practice can save us. Please do it. Thank you. Have a good day. Take care. Bye bye.